Welcome to this Programming for Cultural Heritage lecture. Today we're going to be discussing XML. And so XML is a standard of formatting data, a data serialization. We've already had some familiarity with different types of this, right? So we looked at CSV files and we looked at JSON data, JSON files. But XML is a little bit older than JSON. It stands for Extendable Markup Language, and it's basically a serialization for encoding data. And it's nice because it is, well, it's supposed to be nice because it is good for machines, right? Because it's marked up, the machines can read it, programming can read it, and also you can read it as a human being, right? So it has very verbose tag names and it's very verbose standard, and so you can actually look at XML document and sort of read it uh, as the same way a machine would. So there's lots of standards that use XML for a long time, and lots of different metadata schemas and standards are defined in XML. And it's in use less and less. It's very heavily used in cultural heritage. So if you're involved in those types of things, you'll find a lot of them, a lot of XML files there. It's very heavily used in government. So if you're interacting with government agencies, they're often using XML. And you'll find it here and there. It's useful to know how to interact with it. But one of the most kind of largest repository of XML documents you'll ever find is actually the internet, right? So every single HTML web page is basically an XML document. HTML is just kind of a subset or a different version of XML with different standards and different tags. So, XML is actually the most, um, you know, popular format in the world if you think about how many web pages there are out there. So XML is often interacted with different ways. Like I mentioned, it's human readable, but it's also machine readable. And a lot of folks use XSLT transformations to work with XML, which is very popular in cultural heritage area. So you can do that to work with XML data, convert it, etc. Well, we're going to be using Python for our XML work. So, you probably had experience with XML if you've done any sort of HTML editing or you looked at HTML document before. But basically, an XML is consisted of a couple features, and one of them are tags or elements. I call them interchangeably tags or elements, and these tags basically contain the data, right? And so you can see these brackets title, and then it closes the tag with this / title. So you can say this is the title tag or this is the title element, and it contains a piece of data in it, in this case, a string. The other piece of XML is this idea of attributes. And so attributes are stored inside of the tag, and they're kind of metadata about what's in the tag data itself, right? So you could say the 1776 date here is the content of this tag, the text of this tag, and then it has an attribute called encoding, right? And so this encoding is a string. In this case, it says W3CDTF. And if you look that up, that's just a date format specification, right? So obviously this date is a date element, and it is saying that the content of this date element is encoded with this standard. So if you're a machine reading this, you know exactly what format to expect the data in, and you could even do some like validation, right? You could check it to say like, well, actually this W3CDTF format is not supposed to be formatted like this, so etc., right? So these attributes kind of inform you or the machine what type of data is being stored or information about that data that's being stored in that attribute. A big thing about XML is that it's nestable, right? So we've seen this a little bit with JSON, but with XML, it's everything is nested, and it's all about kind of the hierarchy of the nesting. So if you think about a web page, right? So every web page has the initial element called HTML, and that is the parent element for all of the other elements in the document. The same is true for this XML document. There's one element that holds everything, and then everything is nested underneath that, and you could have infinity nesting all the way down based on whatever data is being modeled. So with Python, you are able to access both of these things, right? The text and the attributes. And one of the things that you should be aware of is that XML is very based on these kind of standards of data standards that are being defined. So for example, there's a data standard called mods, right? And mods is just a way of saying, if you're going to communicate data in the mod standard, then your element should be this. You should have this type of element, and you should put this type of data in that type of element. And so that's what makes XML really powerful, is that it's inherently has these schemas or namespace attributes to them by default, right? So you would most likely not just make up a random XML document. You probably use an existing element schema to kind of talk about your data, right? So HTML is the HTML standard for XML, right? Mods here is the mod standard for XML. And so by using these different standards, it's expecting that these elements will be have a specific namespace or prefix for each element, right? So this is saying, this date created element belongs to the mod standard. And so because it's a mod standard, you could have another element called date created that belongs to a different standard, but this one belongs to the mod standard, and the machine knows that it should be a certain way, and you know that you should put certain data in there, etc., right? So you should always expect that if you're using a standardized XML schema, that there's going to be this prefix on the element tag. It's going to be prefixed somehow. And so to interact with the XML files or XML data, there is a module that comes built in with Python called eTree. And so eTree is a module that lets you interact with files, and it lets you parse them and write them out again. And so there's many other, you could argue better modules to work with XML in Python, but they don't come built in or shipped with the Python itself. So you'd have to install those third-party ones, and we're not going to get into that. We're just going to use what's defined for us, what's already available to us from Python to get started. And so in this case, you could say, okay, I'm going to importing this piece of the module, right? This element tree. I'm going to parse this file, right? And so the difference here is that the parsing the file, you don't have to open it with the with statement yet to pass it to this parser. This does it for you, right? And so you don't have to open it as with open as and then pass that variable to something. It just does the whole thing for you. Just tell it where the file is located and it parses it. And then, like I mentioned earlier, everything has a root, so you have to get the root of the document. And then once you get to that point, it's basically like everything else we've been doing in Python. You can do for loops to traverse the data and loop through the data and the structure. And so in this case, you're looping through the data structure, and you have this ability to look at the contents of each element as you loop through them, right? And as I mentioned before, there's different attributes, or there's different kind of aspects of each element. There's the element name, right? So the title element. There's the contents in the title, right? So there's a title. And then there's attributes. This title is formatted as the specific style, or this date is formatted under this ISO standard, date standard. So you can access all three of those pieces of data in Python by referencing the .tag, .attrib, and .text, right? So the .text is the contents, the attrib is a dictionary of the attributes, and then the tag is the tag name itself. So using those three things, you're able to pretty completely navigate the document and move around the data structures. So let's kind of make this a little bit more concrete, and so we'll do an example together now. And so if you had a XML document, and so there's lots of XML documents out there. As I mentioned, they're very popular in cultural heritage. And so in this XML document we have is it's a document that is a metadata document that represents the Declaration of Independence that's held at the New York Public Library. So this is the digital asset, right? And then the digital asset has this metadata associated with it. And so this metadata is stored as a mods file on the server. And so if you could actually access this mods file, you could see all these data fields and do all sorts of stuff with it, right? So I've posted the mods file for this document. And if we open it up, this is what it looks like. So we can see there is a kind of XML declaration at the top. This is just a thing saying, okay, hey, this is what version the XML is, and this is the character encoding that we're using. So in this case, UTF-8, which is pretty common. And then we have the parent element, right? So the mods element holds all the other elements in there. And then we have stuff like title info, name, more names, type of resource, original info, right? And so these are all elements that are defined by the mod standard, right? So you wouldn't have a element name that was not already in the mod standard. And the mod standard is actually up here in the attributes of the mod element saying, okay, this is mod version 3.4, and here is the namespace that we're using. So we're using the mods namespace or the mods prefix. And if you actually went to this address, you could see the standard, the mod standard documentation, and it has a validation schema, and you can check that this document is actually a valid mods document. But it kind of it references what is its standard being used and how to get more information about it. So XML is very good at this, right? It's very good at namespacing and having specific kind of standards that are definable by the user, right? So this isn't like this is programmed into any programs or anything like that. It's not programmed into the browser or something like that. This is just an arbitrary standard that was created by the Library of Congress, and then folks in the cultural heritage area said, this is a useful standard for us. We're going to adopt this standard to talk about our materials. And so this is the kind of the power of XML, and this is why it became really popular for a number of years, and it's still very popular. All right, so our little task here was we're going to say, let's try to loop through this file and then print out the aspect elements. And then we're going to try to loop through the file and print out all the name parts of the document, right? So let's take a look at that again. So print out the text of the abstract element and then print all the name parts of the document. So here we can say, if we go through here, we'll find the abstract somewhere. There's the abstract. And then it's also, we want to print out the name parts of the document. So here's the name part. All right, so to get started, we're going to make a new file, a new Python file. Let's save this and we'll call it parse xml.py. And these files, this declaration.xml file is in my downloads folder, and so is this file I just created, this Python file. And so if we look at our how-to kind of introduction here, we know we need to import this module to get started, right? So we're going to say import xml.etree.elementtree as etree. So basically, there's an XML module, and it has this etree library built into it. And elementary is the name of that specific piece of the library that we're going to be using. And so instead of having to go through and reference it all the time like this, say like XML this, blah, 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 do stuff, right? We can say import this whole thing as this variable. And so this can be called whatever we want it to be. In this case, we're calling it etree. So it's kind of like reducing this complicated import statement into just this one variable that we can reuse. So then we know that if we want to parse an XML document, we need to use this etree.parse method that's built into it. And so we can say tree or whatever you want to call it. This is our variable. We'll call it document. Document equals etree.parse, and then you give it where the file is. And so if this file was somewhere else on the hard drive, you'd have to make sure to, make sure you give it like a full path if it was on my desktop or something like that, etc. Right? But in our case, these files are in the same directory. So if they're in the same directory, then you can just give the file name. In this case, our file name is called declaration.xml. And that's it, right? So that's how this library deals with it, right? So we didn't have to do like a with open blah 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 blah, right? That's just how this particular library is defined, and you'd have to like read the documentation if you wanted to learn more about the nuances of it, right? All right, so now that the document's open, then we can get the root element, and we'll say document dot get root. So this line opens it, and then this one extracts the root element, right? So this is just the whole document at this point, and then this is just the root element when we pull out the root element. So let's see if this works. We'll just print out the root element and see what it says. So I'm going to run this. We're going to say Python 3 XML parse or parse XML. All right, so it ran this and it printed out the kind of like a textual representation of it, right? So it doesn't know how to represent an XML element very well textually, so it just says this is an XML element and it's at this memory space, right? So it's just saying, okay, this is the elements and this is, you wanted me to print to the screen and this is the best I can do. And so now this is an element root, and so what we can do is there is we can access all those pieces of metadata about it because it is an XML element. And one of those things is the dot tag, right? So if you wanted to print out just the element name, we could do root dot tag, right? And it would print out the name of the element. And so here, this is what I was talking about before earlier with this idea of namespacing. And so the whole element name is http blah 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 lsu.gov/mod/v3 slash or curly bracket mods. So this is the whole name of that element. Even though if you're looking at it in the document, you see it just says mods here, but it's actually being prefixed by the standard, right? So the standard is this whole long string and then the element mods. The same would be true for this, right? There'd be this whole long thing and then title info. So that's the true name of these elements because we're working with this schema called mods. So if you had no schema at all defined, and you could actually do that by taking out this namespace element, right? So if I stripped out all this namespace data, now it lost all its standard, right? We don't know what standard this document's being used anymore. So if I ran this again, we lost that prefix, right? Now it's just mods again. And so what that standard does is it allows you to be very specific about what elements you're using for what standard. You can mix standards together and have different namespaces and have very complicated documents, right? So this is kind of like, again, the power of XML allowing you to do these namespaces and have every single element kind of fit into its place. The kind of the problematic thing for us working with Python is just we just have to remember this is the true name of the element, not just mods, right? It's tempted to say, oh, that's a mods thing, its name's mods, but it's actually, its whole name is this huge long string. Okay, so we're able to pull out the root element, we printed out its name. Now, once we have the root element, we can do what we always do in this Python data structures is loop through them, right? And so we can do a for loop, and we can say for, we'll say child in root. And let's just print out again that their tag name. So we'll say print child tag. So if we run this again, we see, I gotta save the declaration. I put the namespace back in. So if we run it again, we'll see it's the full namespace. All right, so if we run the script again, we can see it says, okay, so that's the one, the first print statement. Then it says title info, name, type of resource, origin info, right? So if we went into the file, we'd say title info, name, type of resource, origin info, right? So it's looping through the top level elements and printing out, just the top level elements. It didn't get into this nesting here because that's not a child of mods. That's not a child of the root element. That's a child of the name element, right? So it's only looping through the children elements. So what we can do is we can pretty much treat this like a Python dictionary, or treat it like a Python kind of a list by looping through different aspects of it, checking where we are, and looping through it, right? So the first challenge we want to do is, can we print out the abstract element, right? So here's the abstract element. So we know it's in there at the top level. And so what we could do is we could just check what the name of the element is, right? So instead of printing it out, we could check it. We could say if child.tag is equal to this name of the elements, right? And again, I'm iterating this because it's a little confusing. You'd be tempted, and rightfully so, to say, okay, the tag is called abstract. But because we're doing this with the namespace stuff, this is the true name of it in Python in this library. So if that's the title, then we can print out the tag name again. And so it just prints out the one. We'll get rid of this other print statement. And like the slide said, we have access to the tag name, right? But we also have access to the text and the attribute. So we can say text, run it again, and then that's the contents inside the element, right? So it looped through all these elements, and when it got to the abstract, the if statement was true, and then it printed out the text. So that's the text there. Um, you can also access the attributes, right? So I have this kind of make-believe attribute here just to demonstrate it. But if you change this to attrib and run it again, you can see the attributes are represented as a dictionary. So you could actually treat this like a dictionary, right? So if you wanted to access the attributes of other elements, you just need to treat it like it's a dictionary, and you could access any of these kind of attributes for that element. All right, so the next one, the request or our little challenge here was to print out the name part of all the documents. And so this probably kind of clicked for you already, but we can see the name part is not at the top level of it, right? And so if you think about how you would navigate this, you could do nesting for loops, right? And so if we, so this is our first thing, so we'll leave that in there. We'll print the text. And then we want to check this again, right? So if we're looping through every top level element, we could change this to check if we're in the name top level element, right? And if we are, then we know that we're here in this block of XML. And if we're in that block of XML, then we can loop through the rest of this one, right? Because that's how XML in this library works. Every piece of that, every element has its own potentially children, right? And grandchildren and great-grandchildren. And so by treating it like we treated the root, we can actually just loop through this child element too. So when we are in the right place, right? So on this iteration of this top element, because we're going through each element, we're at the name element, we could say for name child in child, and at this point we're looping through the children of the name tags, the name elements. So if you run this, let's print out the tag name and then the text of it too. Put a comma there. So it's going to print the tag name and then the text. Right. So it got to the name part, which is a child of the name tag, and then so it printed out the name elements, tag name, and then it printed out the value, right? And it got to the role, and it got to role, and there was no textual value, right? Because the role is actually another nested element, and there's just more children or grandchildren living underneath the role element. So if you wanted to get access to the role element, then you'd have to check to see if you're in the right place, and then add another a loop, right? And then it got to the name part again for the next one. So it finished with this one, and it got to the name part for this one, and it printed it out. So doing this way, you could potentially navigate any kind of hierarchy of the document and get to any piece of this data and print out the values you want it to get to. All right, so that is one way of doing this. Just for your information, we're going to kind of look at it a different way. And so you'd probably be saying to yourself, this is extremely kind of verbose, right? This is very elaborate to get to some piece of information. It's very difficult to work with, right? And so, of course, people who invented XML thought the same thing too, and they came up with this solution called XPath, which is basically a way of querying an XML document, which is kind of interesting if you think about it, because um, you know, you know, it's kind of a standardized ways of querying a specific data type or specific data serialization. And so, XML is pretty old. XPath came around in 1998, right? So it's very old. But it's basically a way of standardized language of querying a XML document. And so Python has implemented the standard into its eTree module. And so let's comment this out here. So we can use this XPath query. Python has built in this XPath feature into this eTree element tree module. And so we can use it to kind of simplify searching for a specific element that we want. So each element has, just how it has these tags and text built into it, it also has this find method and find all method built into it. So let's try printing this. So we can print out the root element, right? So that's everything goes in the root. We can say find this specific XPath query. And so if you just give it an element name, so in this case, the abstract, I want you to say, we're saying, okay, basically find the first abstract that you can, regardless of where it is in the document. So if you ran that, we can see that it found it, right? And so we could say, okay, we'll say abstract equals this thing, and then we can print the abstract text. And there we have it, right? So we didn't need to loop through anything. We just used this built-in XPath query to find exactly the element that we wanted to work with. But if you did want to accomplish the second one, right, where we're looking for the name, we know that there's not just one abstract, there's multiple abstracts. So the root, these elements actually have, we'll call this name tags equals root dot find all instead of find. And so the first one is returning the first one I found, the second one, find all, is finding everything, right? And so we can say find all of these elements. And let's see what that comes back with. Print name tags. And so we can see here it is, we see these curly brackets, right? And so when seeing those curly brackets, we know that it's a list, right? And that makes sense if we're trying to find all of the elements, then it's going to return it more than one, so it has to return it as a list, right? And so it says it found two name elements, right? And it just says it's not very good at printing this to represent this as textual data, so it just prints out this kind of like representation of its node. So the nice thing about XQuery is that it's its own language in itself, and it has various rules about it. But if you do a element name, right? So this whole thing is an element name, and we put / and then this other element name. It will say look for this element that has a parent of this previous element, right? So it's going to say look for the child element name where the parent element is name. And that's of course not right. So we say we want to find the name part, right? So we're going to say find all the children name parts where its parent is name, right? And again, this prefix stuff is super annoying and it kind of gets in the way. But if we remove that and just kind of for temporary, see it's saying find the name part where the parent is name, or find the children of name where the children are called name part. So putting back in those full namespaces, let's see what happens again. And so it came back with another list, right? And there's stuff in there. It's found the name part. And so what we can do is, like we do with any list, is we can loop through it, right? And so we could say for name part in name tags, print name part, and print out the text of it, right? So there's the two results too. So these are comparable ways of doing the same thing, right? As we always say, there's multiple ways of doing things. This is a little bit less frustrating because you can query, you're basically writing a query to find a document. The downside is you have to know how to write next query. This first part is a little bit more frustrating because it's just very verbose and kind of a lot of looping. But if you're familiar with for loops and that's all you're familiar with, that's really all you need to get through the document. So both ways are valid ways of doing it, just depending on which way you want to access the document. So that encompasses reading an XML document, which will be kind of a big part. If you use this library to parse various XML documents, you definitely want to be able to read it, right? And also the second part of that is writing an element, right? And so the XML module provided by Python provides these three submodules to control creating elements and writing them out. And so you can also import these three element, sub-element, and element tree. So we've already imported element tree, right, as E tree, but you can import this element and sub-element piece of the module that lets you create elements and create an XML document, and then you're able to write that out. So in this case, you can use the element function that you've imported to create an element, an arbitrary element, and then you can use the sub-element to create an arbitrary child of that element that you just created, right? And so by doing this, you can create an infinitely complex and nested XML document, which is with just those two functions. And then you can do things like set the text, right? Anything that you can read, right, that we were doing before. So you can set the text of the element, and you can also set the attribute by using the set method. And then you can write out the whole document to a XML file and save it off. So just to kind of cement this, let's do this together. We'll make a new document. We'll call it XML write.py. And so to begin with, we need to import, we need to import the XML module that we're going to be using. So I'll say import xml.etree.elementtree. We're saying from this. It's a little slightly different from before. So we're saying from this module. Before we're saying import this module as this new variable name. Now we're saying from this module import just these three specific things. So we're saying from the elementary module only import the element function, the sub-element function, and the element tree. All right, so now that we have it imported, we can start creating elements. And so we can, every XML document has a root, right? So we can say create a root node. We'll say root node, and we'll just create an element. And so in this case, if you were going to be building a standardized XML document like mods or EAD or anything else, you'd want to make sure you're using these prefixes and define the namespace and all that. So if we're just creating we're kind of creating our own XML standard here, so we could just say let's call it test root or something like that, right? Just as a demonstration. And so once this element has been created, you can do things like write the text to it, right? There's space there. We can do something like set the text equal to hello, and then you can do this final thing where we're writing it out to a file just to see if this works. So we'll say elementary. So you say elementary, and then you pass it the thing you want to write out to the file. So in our case, it's the root node, and then you say write, and then you tell it what file name to call it. We'll call it test.xml. And again, right, we don't need to do it with open or anything like that because that's just the way that this module works. It does that for us. So let's try running this. We'll say Python 3, it's called XML write. So no errors, so that's good. So we'll take a look at this, our XML file. Right, and that's kind of like what we expected. We only have one node, and had some text in there. So if you wanted to set an attribute right of this, we could say root node dot set, and we'll say type equals test. Right, and these are just arbitrary things. This is the attribute name, and then this is the attribute value. And it can be whatever you want. If you were using a standard, there would be a limited number of attributes you could use, and you would have to reference the standard to see what attributes are available for what elements. But we just kind of make this up, so this standard up. So we reload that and see now it has a attribute. So the only other thing is being able to create we'll comment those out, being able to create a child node of this root node, right? So to do that, we need to use the sub element. So we'll create a new element called child element, and we'll say that is equal to the result of taking the sub element function, passing it the node we want to create a child on, and then what we want to call the child. So we'll call it test child. And then that kind of, right, because you need to pass it both things. You need to pass it where do you want to create this child, and then you need to pass it what do you want to call it. And once that's passed, you have it available. It's kind of created in memory, right? In this kind of memory structure, it's inserted that child node into that root node or whatever element that you created on. So then we could do something like child element.text and set that equal to, I'm a child element. And then we'll leave this piece here where it's writing it out again. If we run it again, it creates the file again, take a look at it. So now it has this structure to it now, right? It's nested, it has a hierarchy to it, and it has a test root and it has a test child. And the test child has some text in it. And so the one downside of this XML module, maybe not the one, but there's no way to pretty print when you write out a file to XML using this module. So usually you could, if you have an editor that lets you do plugins, there's usually a plugin for like formatting. So like in my Sublime editor, I have indent XML plugin that will just format the XML for me. So that's kind of limited. It's like JSON has that indentation feature, but this module does not have that for its XML output feature. But using these two elements, or these two functions, the element function and the sub element, you can create an infinitely complex XML document and add in text and add in attributes and all the stuff that you'd want to do to create a fully well-formed XML document. So the challenge this week is a kind of very practical challenge where we're looking at doing some data transformation. So this is often called ETL. So you're extracting, transforming, and loading the data. This is a very common problem where you have data in one format and a system expects it into another. So you have to go through a process of changing it and getting it ready for the next system. In this case, we're going to be kind of replicating a practical issue that happened. So there was a collection at the New York Public Library called the Sanitary Commission Collection. And this is basically an archival collection that has the records of the Sanitary Commission, which was a organization during the Civil War that took care of wounded soldiers and other types of things like that. So there was a boutique kind of website that was built that displayed this information for these soldiers that were treated by the Sanitary Commission. And so what happened was the site was shut down, so that data was no longer available online. It was basically stored in as a database, and it had basically been exported as a CSV file. And so what you could do is you could say, okay, well actually I'm going to take that data that was outside of the collection, and you could put it into the finding aid for that collection. And so, for example, this is the finding aid for the United States Sanitary Commission Hospital Directory Archives. And so you could actually, if you could find a way to format the data to put it back into this finding aid, then it would still be available, right? And so basically the way of doing this would be to format the data from the CSV file back into an XML format that the archival standard of EAD could recognize. So EAD is the kind of archival XML format that represents archival data. And so the challenge would be to take the CSV data and convert it into this XML EAD format data, and then you could put it into this finding aid. So let's take a look at the file that's provided to you. This is a file called msssoldiers.csv, and so this represents the CSV database, right? The boutique website data. And so you have no header here; it's just data here. But if you look through it, there's some various names and their position, their rank, maybe their age, some dates, etc., right? And then if we look back at the notes here, there is a field list for us. So this is like the position, the index position in the CSV, and then what that piece of data is. So you have all sorts of information there. So the challenge would be to take this data and format it into a way that is represented well for the XML format, for the EAD format. So what we're going to be doing is there's actually a standard. We talked a lot about how XML is full of standards, and there's a standard for representing this type of data in an EAD XML file, and it's by using this index element. So basically, you'd be using this index element to represent that data, and the point of this index element is that it is kind of to help someone locate that piece of data, right? So if they're looking for this index data, it's kind of like, I want to find the record for this soldier that was treated. You'd have this index information, and it would basically say, okay, do you want this information? Head over to this box of the archives and pull out the data, the record for that person. So in this case, they have an example of the index element being used, and it has a little bit of information about it, and then it has this index entry, and it has the name, and then it has the ref. And so the name is, in our case, would be the name of the soldier, and then the ref is, how do you access this piece of data in the archive? So how do you get to this document in the archive? And so if we look at the format of this, we can see that it should look something like this. So we're going to have an index element as kind of like the root element. Then we're going to have an index entry. And so for every soldier, there's going to be a repeated index entry for each soldier's name. And then there's going to be some elements inside of there called name, note, and ref, right? And the name is, of course, the name of the soldier. The notes is anything else you want to put there. And the ref, they access this piece of information in the archive. And so the structure would be all you need to turn the CSV into an XML document, and this would basically be kind of the rough way that they would look. So the second, if you wanted to try a different challenge option, you could try to create not just an XML document for this data in the EAD standard, but you could try to create an HTML page for this data. So say you wanted to take the CSV and just make a static HTML page for folks to use. You could use the same techniques we just learned to write an HTML document instead of a EAD XML document. So we're going to try, we'll go through both really quickly. And so you might probably want to maybe pause the video here and give us a shot, and then come back and we can review it together if you got stuck. So we're going to start off with the first challenge, right? So we're going to try to create a new XML document from this CSV document. All right, so we know if we think about the data that we have available to us, we know that the source data is going to be the CSV file, right? And we know that the end result should be an XML file. And so knowing that, we know we need to use the CSV module, and we know we need to use the XML module. And especially writing the XML, right? Because the source is not an XML file to read. We're going to be writing them out as XML. So knowing that, we can start a new file, and we'll save it, and we'll call it XML transform.py. And so now this is our Python file. So we'll say we know we're going to need our CSV module, right? Because we're going to read a CSV file. And we know that we're going to need our XML creating abilities. So we can actually just copy that from our write example, right? So we'll Just copy paste that. But from the XML tree module, import the element, the sub-element, and the element tree functions because we're going to use those to write elements and write out to the file. So to get started, we got to think about, okay, so we need to loop through the CSV. And so we know how to do that really easily, right? So we'll say with open, and then the file that we're working on is called msssoldiers.csv. It's in the same directory. We're going to open that for read as, let's call it MSS file. And so, of course, we know that to work with CSV, we need to read this and parse it. So we'll say parsed or processed CSV.reader, right? And we'll pass the open file pointer to where it's being read as. And then, of course, we just need to loop through it, right? For row in processed CSV, right? Row. All right, so let's take a look to see if it works. We got our file names right. Python 3 XML transform. Great, right? So that's printing out the rows of the data that we want. So we got to think about what we want to store here, right? So if we go back to our list of fields, we can see that we have the ID, last name, first name, other name, unit number, unit state, unit type, unit letter, rank, additional info, alt info, year, box number, folder number. So if we think about this, we would say, okay, this first name, last name, other name, that seems like a good piece of data to go into our name field. Unit number, unit type, unit letter, rank, additional info, alt info, those 4 through 10 seems like a good place to go into our note field. And then the final one, reference. How do we actually get to this year should be also being included in the previous group. And then reference, where is this physical thing stored in the box number, what folder number and box number, right? So these last two are for those last fields. So if we can think about this, we want to populate 3 strings, 1, 2, 3, and we need to build each of these strings up, right? So let's go back to our code here, and let's just define those 3 strings to get started with. So we want the name field to equal something. We want the note field to equal something, and then we want the ref field to equal something, right? So now our first goal is we just need to build these strings that we were going to put into these fields. So we know that the name field probably can be composed of maybe the last name, comma, first name, or something like that. So we can say name field equals, we'll start off up here, right? Name field equals, since we already have that. We know it's row, last name is stored in number 1, row 1 plus a comma and a space, and then row 2, which is the first name, and then we'll put a space, and then we'll put other name. But right, so other name, they probably don't always have an other name, right? So what we could do is just leave it at that, and if it does have an other name, right? So if other name does exist, so if there's something, if it's more than just an empty string, right? So let's look at some of these here. So last name, first name, other name. Here's last name, first name, other name. Here's last name, first name, other name. So in this case, the last name is Yerb, first name is Marion R, and then the other name is Zerb, Marion R, right? So there's like maybe some confusion about the spelling. So we definitely want to get this other name in there because, you know, it could be important for someone trying to find this record. But we can see when there is no other name provided, it's just an empty string, right? It's empty. So we could say if row and this is stored in other name row 3, is not equal to nothing, empty string, then basically toss it on to this to the name field, right? We'll say name field equals name field plus a space, right? Plus the um, row 3. So we basically combine these 3 things together into a new single string. And so what we can do is we can just print this now before we even get into our XML stuff, right? We just want to make sure that this is working. Run it again. Let's turn off the print row for a second. Run it again. And we can see a bunch of names being printed here, right? One thing that looks pretty bad, right, is that there is a lot of space here, right? So there's some extra spaces here. So what we can do is there's probably some extra spaces in these rows, right? So this is probably like the last name space, and this is probably first name space. And what we can do is strings have a lot of methods built into them, right? Remember we saw uppercase, lowercase, find, replace, all that sorts of things. So one thing built into them, one method built into them is called the strip method. And this basically removes white space from the beginning and end of the string. So let's put it here too. And so basically what it will do is if it says, Miller space, and that's the field, it will strip that space and it will just say Miller, right? So it should hopefully make things a little bit prettier. Yeah, right, this looks pretty good. The only other thing, right, is this might be confusing if it says right, Barrett's White, Bartle, right? Still confusing. So because it's kind of like, is this the first name or whatever? So you can make this a little bit more explicit and say parentheses, alt name, space, and then add another closing parentheses. So these parentheses are just textual, right? They're parentheticals in the text to make it look a little bit more readable. So then we have, right, this is a little bit better, right? So Ludwig Young, alt name, Young Lewis, right? So it makes the string a little bit more readable. And so this is interesting, right? We're kind of going the opposite direction, right? We're going from very structured, very highly structured text to big string blob, right? So of course the structured text is better, but if you're going to just be putting it into a kind of like a text field, you'd have to, mush it together into this big string. All right, so our first thing is done, right? So to review, we're trying to get towards this name field for each soldier name. Now we need to build a note field. So the note field is really up to you what you want to put into there, but I would just say let's put everything else in there that's not the name and not the box folder number, right? So we could just build that string up here. And so I'm going to show you a little shortcut here that is new in Python 3 for dealing with formatting strings. So normally how we did it here, right, we kind of built a string up by adding them together, right? So we're like concatenating things together. And so we have to be very conscious of what we're concatenating. So here, like we're saying comma space, right? And so what's new in Python 3, which has been around for a long time now, but a new thing in Python 3 is that you can do these template strings, which allow you to easily format a string easier. And so what you can do is by saying this string is not just a normal string, it's a template string. And what you can do with template strings is insert variables into the string formatting itself. So let's go through this and say like, okay, unit number. So we know that's the unit number. And so what you can do with a template string is using these curly brackets, you can put in the variable that you want to plop into the string itself. And so that's number 4, row 4, or column 4. And so basically it's saying, okay, take this string and wherever you see curly brackets, put in the variable, the text content of that variable, wherever there's curly brackets. So replace this with the actual value of row 4. So let's try printing this and see what it looks like. So in some cases, there's question mark, or I'm sorry, there's like no unit number. We could probably do something more elaborate. So yeah, sure, let's do that. So here we're kind of referencing the row column for very explicitly. So what we could do is we could create a new variable called what is this called? It's called unit number, right? And we can make that to equal to something. So we could test it, right? So we could say, okay, if row 4 does not equal nothing, or we could do the opposite, right? And say if it equals nothing, then make the unit number to unknown, right? And if it's not equal to nothing else, then make the unit number equal to row 4. And we'll add that strip just to make sure it's a clean string there. So basically we made a new variable. Unit number is either going to be equal to unknown, or it's going to be equal to, equal to the actual value of row 4. And so now we could replace that with this new variable we created. So if you run it again, now we have unit number unknown, and there's no empty spaces, right? So let's do that for the other variables that we're going to be creating here. The next one is going to be unit state. Oops. So we'll say underscore unit state, and this is stored in column 5, so that's 5. So let's make these variables first, and then we'll come back and put them into our template string. So row 6 is going to be unit type, and row 7 is going to be unit letter, and row 8 is going to be rank, and row 9 is additional info, and it looks like 9 and 10 are info, and 11 is year. So we could maybe just mush those all together, right? So we'll say, we'll just make a new variable called info, and we'll have that equal to row 9 strip plus space. I can use a template here, but I'm not going to. Plus row 10 strip plus row 11, column 11, right? So we have additional info, alt info, and year, and we'll just kind of mush them all in together. And then we could, what if there was like 3 where they're just empty spaces, then you have a bunch of empty spaces. You could say, okay, info equals info dot strip. Just kind of make sure there's no trailing spaces there. All right, so we've basically made new variables for everything, right? So now we could come in here and say, okay, we have unit number done. We'll say unit, next one is state, is unit state. Next one is unit type, I believe. Unit type. Next one is unit letter. Next one is rank. And then the last one is info, right? And we'll just we can say info, it's fine. So this is like kind of like a user experience question, right? Like what are researchers looking for? How would they expect this thing to be formatted if they're coming in looking for a specific document relating to a specific soldier, right? But at least the data is all there, and it's at least in this field, so you could parse it if you're reading the finding aid, you could see it. All right, so that's our note field. And then the last thing we got to create here is this ref field. And so the ref field is just the box number and the folder number stored in column 12 and 13. And so we can just say ref, we can use a template string here again. We can just say box, and then we could say, we're assuming it's always going to be there, right? Because why else would it be in this finding it if it didn't have a box and folder? So that's going to be in column 12, and then we'll say folder, and that's going to be in folder or column 13. All right. So now we have our name field, note field, and ref field, right? So let's print that stuff. Name field, ref field, and note field, and ref field. Let's print a little divider here just to test this. So if we ran this, we should see, so we have an error here. It says something happened on line 43. You can see I don't have a plus mark there. So line 43, I'm missing a plus mark to join this string together with this variable. All right, so no errors, so it processed all its text successfully. And everything looks pretty good, right? You might be probably come in here and make some some changes. You probably maybe make the year its own kind of heading, have a year heading or something like that. But this kind of, you get the idea of what we're doing. Box and folder look good. Things you'd want to check is like, is data repeating? Is it all the same data? Did I mess up somewhere? Did I use wrong variables? But everything looks kind of correct, right? All right, so now that we have that ready, we have the raw materials to go into our XML file, right? And so our final thing is now we need to actually write this out as an XML file. So this was only like half of the thing, right? We're just getting ready to actually do the thing that we came to do for. And so now we need to really think about how this should work. So let's look back at the structure again. So we know that there's a root structure called index, and then there is a index entry element for every single soldier name, right? And inside of that element is the name, note, and ref elements. And so this index entry thing would be repeated, thousands of times for how many soldiers' names there are, which is a good question. How many are there? There are total 9,300, right? So this also shows like why you never want to do this manually, right? It's nice to have these Python skills that you could actually generate this file. Because to write this out 9,000 times, right, it would take a long time. All right, so we got to think about the structure again. So we have this index is the root, and then we have the index entry, and that's repeated. So we know we need to create the root element somewhere. So this is key, right? We got to think about how the flow of the program works. So everything comes through here, and then once it hits this point, it's looping. So everything inside of this for loop is happening over and over for each soldier, right? So we know if we're going to create the root element, that has to happen before it starts looping. So let's create it here. And actually, let's create it up here because we want to kind of have it available to us throughout the entire program. If we put it here, as soon as this with block is closed, then we lose that variable. It's not available to us anymore. So we want to put it up here so it's still available to us throughout the entire program, even if we close and unindent outside of that with statement. So we know we need to create an element. So we'll say our index, right? That's the root element. This is just a variable name, so it can be whatever. But we're going to use our element function to build this index element, right? So now we have an index element. And so now if we think about this, we know that as soon as we get to the for loop, it's going to start repeating, and we're going to want this element to repeat each time, right? So once we start repeating, we can create that new element here as a child of it, right? So we're going to say, um, we'll call it soldier, no, we'll call this index entry. Index entry equals sub element, right? So we're going to create a sub element. The parent of the sub element is the index element, which is stored in the index variable, and the name of it is going to be index entry. All right, so now that we've created that, we've created this one, right? And so now we're going to go through and it's going to create all the data. And at this point, where we're printing it out, we're going to stop printing it out, but we have that data ready for us. And so we need to create some new fields, right? So we're going to create the name field, and that's going to be using a sub element, right? And the sub element, you have to pass it who is the parent, and the parent of this is the index entry. And even though it's the same name, these variables are reset for each iteration, right? So for each iteration, it's a new index entry being created, new node field being created, etc. So the parent is the index entry, and the type of element it is going to be the name element. So this created this, right? This generated this structure into the memory of the XML hierarchy. And so now we could set the text of it. So we could say the text should be the soldier name, which we have already here in the name field. So now we just need to do this 2 more times, right? So we need to create, we're not creating the name field anymore, we're creating the node field. This is just a variable, right? But that is still in this index entry, it's just another child of it, so that's the same, but now it's called notes. And then the we'll get rid of that underscore there, node field in both. And then we want to store, spelling field wrong this whole time, but that's okay. We won't stop now. Node field is stored. So this is a little confusing. Name field, we'll call this name field element, because it's getting confusing. And we'll call this node field element spelled incorrectly. Always check for typos. So the name field is there, but now we have this name field element, which is the element, and then we're setting the text value to the string value. So we created for that one, for the note, and the last thing we need to create is the ref element. And this is in the same parent, and it's called ref. And we have the ref field, which stores the string. Right, so it's generating that for each iteration. It's going to get bigger and bigger and bigger, and that's all that's really involved in the structure. The last thing we want to do is write it out. And so I'm going to unindent. So this is the last thing we're going to do. We don't want to do it in each loop. We want to do it when it's done looping. So I'm going to unindent out of the for loop and out of the with block. And our root node is called index. So we're going to say index dot, oh no, so we have to do elementary. And then we say index and we say write. And then the name of the file called MMS soldiers.xml. So it's going to come in here, make the index element, loop 9,000 times, creating a new index element for each loop, putting that as a child of index, and then creating these 3 as children of the index entry. And then the last thing it's going to do is write out that whole structure that's been created in memory to a file. Let's see what happens. All right, so no errors. It came back fine. So let's look at the file that it created. Here it is. It's there. It's 1.9 megabytes. And it looks like XML, right? And so again, this is the problem with this library. It doesn't let you do pretty printing, but I have this plugin in my editor that will format it for me. And we can come in here and see that it looks pretty good, right? There's the index entry for each element, and then the note, name, and ref for each soldier. So, if you spent a half hour making the script, you could generate this XML document and just hand this off to the system to put this into the EAD file, and then that data would be available again today. So the other aspect was let's do the same idea, but instead of doing this to make EAD files, or XML files, let's make an HTML file, right? Let's make a web page. So the idea is very similar, right? So I'm going to save this file as, it's called XML transform. I'm going to call it HTML transform. And so if you think about, you'd have to know a little bit about the structure of how HTML is supposed to be formatted. But we're basically saving the same data, right? We're going to reuse the same script, but basically change the type of XML being exported, right? So before we were putting out XML that was conforming to the EAD standard, now we're going to put out XML that's HTML standard, so basically HTML file. And so if you think about this, you'd have to know some bits about HTML, but there's basically a root element called HTML, and then there is two children elements of that. One is called the head element. And so we would need to make that a sub element of the HTML file, change the variable name to. So HTML is the parent, and the sub element, child element, is called head. And then we also have a body, and the body is where all of the HTML goes. All right, so now we have the head and the body. I'm not going to get too complicated with what this would be, but let's just make a, we'll make a div element for each piece of data, right? So we'll say soldier name, notes, and box, and then we'll put a line, and that will be our basic HTML page. We need to have a parent div, so we'll call this parent div, and that will live in the body, right? And it's going to be a div. An HTML div is just kind of like a dividing element. And so now we have a place to put these, and we're going to slot in all of these pieces of data into the parent we just created. So for all of them, the parent div is going to be the parent of these elements, and each one of these is going to be a new div. Instead of name, note, and ref, they're just going to be divs, right? Everything becomes a div now. And so basically we created an HTML with a body, and there's a parent div with these three divs in each one with this data in it. So same idea though, text is just the stuff inside of the HTML tag, same as XML. So we're going to change this from XML to HTML, and we're going to write it out. We change the index to HTML variable name, so we change that variable name. Let's see what happens. This is Python 3 HTML transform. All right, no errors. So let's take a look at this in our browser. I'm going to drag the HTML file to our browser. Okay, so it rendered the HTML file, right? It's not super legible, right? But you can come in here and do all sorts of stuff, right? HTML is infinitely stylable, changing the styles of the sheets, styling sheets and stuff like that. So you could theoretically come in here and say like, okay, this parent div. So I want the parent div to have a attribute, have a style attribute, and the value of that style attribute is going to be padding, I will say margin bottom of 10 pixels. So this is actually going to create this div and then set this as an attribute, a CSS style as attribute. So if you run it again, refresh the page, add a little bit of a padding there at the bottom, a little margin at the bottom. We got another rule here. We spend all day doing this, but we'll say border bottom 1 pixel solid black. And if we run it again, generates a new HTML file, Let's refresh it. So now we have dividing lines at least, right? All right, so again, you could spend as much time as you wanted structuring this to look a lot better than it does now, but you get the idea where you'd be using basically the same way as you were making an XML file, but you're just making a HTML file. And of course, we could look at the source of this and see, like, here's that style element that was created with the CSS style information, and there's a lot of divs, and it's all one line XML file. But yeah, so I think that brings an end to our challenge this week. Hopefully that made sense. XML is, as I've been saying, it's very powerful and it's very flexible, and you'll still come across it occasionally. So it's a good thing to be aware of. It definitely is less used as it has been, over the last couple of decades, but still a very powerful and flexible standard. So thanks for watching, and I'll talk to you next time. Bye.